So first of all, let's make one attachment. We drag it up a bit. If I don't select the attachment, it's not visible. I don't know where it actually is, but if I press on the attachment and I press visible, it now will show me where the attachment is at all times. This is pretty interesting just for a visual. So you can drag the attachment around. We're gonna duplicate it. I'm gonna name the second one. Let's do attachment 1. Name the first one attachment 0. So right now let's make our beam. So we're gonna have to parent it inside one of the attachments. So just pressing the plus button over here, add a beam. And so first off, I'm gonna explain to you how the shape of the beam actually works. So the beam itself, it works by a mathematical equation called the Bezier formula, the Bezier curve. And it's basically made up by placing 4 points along one line and then having one curve being drawn that represents the path of that line. So right now, right here, we have 2 points. Put attachment 0 to 0, attachment 1 to attachment 1. When you put 2 points, it makes this one singular straight line, right? So now we see it's like a sheet of paper, basically. Curve size. Curve size is basically you placing, or this invisible dot around the place so that you can, tell your beams how to generate. So let's say that we move the curve size 0 to, let's say, 6. And we drag this, we rotate this boy a bit. I'm gonna rotate 45 degrees. You can see every time I rotate this, the beam is generated. If I rotate it over here, it's being brought over to this side. If I rotate it over here, it's being brought over to this side. This is where the invisible dot comes into play. This is basically where it is. And I move the curve size to, let's say, -2. So now you can see that this one has its invisible dot put over here. So we move this around, you can see that the first dot is over here, right? And ignore that. That's motivation. Yep. Anyways, so the first dot is over here, while the second dot is over here. So it generates the curve from here to here, and then bending a bit to here. So we can just keep rotating this and you'll see. Anyways, let's set these to 0 and talk about the rest. Continuing on, face camera. So basically right now, this beam is acting like a paper, right? The paper itself is scrolling. So if I press face camera, it makes the paper face me at all turns. So if I'm spinning around it, basically just faces me the entire time. And if I go to the edge, you can still tell that it's a paper, but it's basically spinning and turning its face on you. So it's facing you, the camera. Go down here, I can change the width of the beams. The width determines the width of the beam at the attachment either 0 or 1. This one is 0, remember? So let's say that we turn this up to 10. Now this is 10 studs wide and it's going the attachment 1. Let's make it a more manageable size. So like, let's say that we set the width to 4. So now you have 4 studs worth of the width. And let's say that we make the width over here a 0. So you just made a triangle. Not really useful, but that's cool. And let's say that we want to make this a 3. So you can see that, let me just turn off face camera. So you can see that this is 4 to 3. Color, scroll around to change the color. If you press enable and disable to enable and disable, light emission shows you how much light your beam or your image in this case is emitting. So you can turn it super up and it becomes really bright, or not that bright. Light influence tells you how much your environment is affecting your beam. In this case, the light is very bright, so it's making my beam already kind of bright. But if I set this down to 0, then you can see that this just basically becomes a solid color and it's not moving anymore. However, when you turn your light influence down to 0, there's a special cool thing that happens, right? You get access to the option known as brightness. This basically lets you change exactly how bright your beam is. So right now it's at 1, which is the basic brightness. If we turn it up to 10, it becomes really, really bright. And you can also stack this along with light emission. And then light emission stacks on top of that. So it makes it even more bright, which is interesting. We're going back to 1. 1 is the basic color, right? It's the same as the one over here. If we go down below 1, it slowly turns our beam darker and darker until at 0, it becomes black. Also, funny fact, if your beam is at absolute black, so either 0 or the color just changed to black, and you put light emission, you'll make it disappear, because light hates black. Yeah. Anyways, let's say that we go back to a normal color now. Let's set this at 4. Set this at 0.3, so we just have something to work with. Texture. So basically you can have different beam textures that you apply onto this. So it's kind of like drawing a picture on a paper and just having a scroll past the paper. It's pretty cool. So right now I put this picture onto the beam, right? So it's scrolling from this point to this point, which is pretty rad. Texture length over here changes depending on what the next setting you use, which is the texture mode. Right now we have stretch, which means that when I move one attachment, the beam itself will stretch. So let's say that I stretch this all the way over here. You can see that the beam is stretched, right? It's like a beam, you know, it's stretched. And when I move it closer, you can see that it's actually compressed, so it's much tighter. This is stretch. You can also see that if I move it super far, and I change the texture length to higher, the texture length you set will affect how many tiles of the texture will be stretched across the beam. So right now we have 5 stretched across it, and if we go down, right now we have around 1, and we go even more down. Right now we have 0.1. Let's set it back to 1 just for the sake of research. And we brought it back to a normal distance. Next, going to static. Static makes it so that the textures are tiled out at the length of the texture length that you set. So right now the texture length is at 1, which means for every 1 stud, which is the unit of measurement, right? For every 1 stud, there will be 1 of the texture gathered. And if I stretch this a bit longer, for every single stud, there's 1 of the texture tiles. But if I change the texture length to longer, so from 1 to let's say 5, you can see that for every 5 studs, there is now 1 texture. So I can stretch this even longer, and it becomes less compressed. And what's going to be even cooler is if I set it to like, let's say 10, it becomes uncompressed and really stretched out. And if I set it to 100, which is 1 single tile of image for every 100 studs, which is pretty big, because 100 studs is really big actually. We'll set it back to, let's say, 5 for comedic purposes. Static and wrap is currently the same. There's no difference, so just use one or the other. But I like static because, you know, it just sounds better. Anyways, continuing on. Texture speed makes it so that your texture scrolls by faster. Right now it's at 1. If we set it to 5, you can see that it's scrolling 5 times faster. And if we set it to like 10, it goes super fast. And one cool thing is that you can also have negative or slower texture speed. So if I put it at 0, it's not moving, right? But if I go below 0, then it starts moving backwards, which is pretty interesting. You know, if you needed to go backwards, forward, stop, go backwards, forward, whatever. Transparency, really basic stuff. 1 means that your texture is fully see-through. 0 means that your texture is not see-through. And you can have this graph over here, and it changes. So like, if I move this higher, the top is 1, of course. If I move this higher, then that means on this end, the whole beam is going to be see-through. If I move it to middle over here, you see it's only a little bit see-through. If I move it to like really tip-top, and the whole thing is really close to being see-through. So the Z-offset basically determines how far away the beam is from the screen. So let's say that we put 5 studs. Basically the beam becomes 5 studs closer to your vision. So you see over here, right? It looks like it's closer than the parts next to it. And if I do -5, then, you know, it goes back. So this looks like it's further than it actually is. The location itself that it occupies is still between the 2 dots, but it just looks like it's further away.